So for part A of this question, we need the gradient, which means we need to know the coordinates. So let's have a look at that. So we've got x equal to 5, which gives me y equals to x squared minus 2x, so 25 minus 10, which is 15. So my first coordinate is 5, 15. And I need to know what the y value is when x equals 5.1. So x equals 5.1, my y is equal to 5.1 squared minus 2 times 5.1, which is 15.81. So that gives me the coordinate of 5.1, 15.81. So those are my two coordinates, so therefore my gradient is equal to 15.81 minus 15 over 5.1 minus 5, which is equal to 8.1. For part 2, we've got that f of x equals to x squared minus 2x. So we want to find and simplify an expression for f of 5 plus h minus f of 5 over 8h. So we've got f5 plus h squared. Let's just start by expanding out 5 plus h squared. That's equal to 25 plus 10h plus h squared. And we know that 2 times 5 plus h is equal to 10 plus 2h. So therefore, f of 5 plus h minus f of 5 over h is going to give me 5 plus h squared minus 2 times 5 plus h, so 25 plus 10h plus h squared minus 10 minus 2h. So that is my expression for f of 5 plus h. I want to take away f of 5, which is 15, and I'm going to divide that by h. So let's simplify this. This is going to give me the 25 is going to cancel with the 10 and the 15. So that leaves me with 10h minus 2h. That leaves me with 8h plus h squared over h, which equals 8 plus h. So I have that simplified expression. So for part 3, it's asking me to use my result that I've got in part 2 to find the gradient of the curve with y equals x squared minus 2x at the point where x equals 5, and I need to show my reasoning. So for part 3, dy by dx is going to be equal to the limit as h tends to 0 of f of 5 plus h minus f of 5 over h, which is the limit as h tends to 0 of 8 plus h. So as h tends to 0, that just leaves me with 8. And finally, for part 4 of this question, we want to find an equation to the tangent of this curve at that point. So we now know the gradient. So if we can use what we've worked out from the previous parts of the question, we know that at x equals 5, we know that we had y equal to 15, and we also know that we've got a gradient of 8. So therefore my tangent is y minus 15 equal to 8 times x minus 5. And they haven't asked me for that in a particular form, so I'm just going to simplify this, and I've got y equals to 8x minus 40 plus 15 is going to give me minus 25. So I've got an equation for my tangent. So we found the equation of the tangent at that point. It now wants me to find the area of the triangle that is formed by that tangent and the coordinate axes. So let's just think what we know about this tangent. If I had my coordinate axes, if I get a quick sketch going on along the side, I've got a positive gradient and I'm intercepting at minus 25. And it's asking me to find the area of the triangle that is caused by this. So the triangle that we want is this triangle in here. So we need to think about what the other intercept is. We know that when x equals 0, we had y equal to minus 25. So here we're looking at what happens when y equals 0. And when y equals 0, x is going to be equal to 25 over 8. That should be a positive there, so my x is equal to 25 over 8. So this coordinate here is 25. So from there, we can now work out the area of my triangle. So my area is going to be 1/2 times by 25 over 8 times by 25, which is 625 over 16.